The hidden frequencies. How everyday devices disrupt your mind and body. Modern life is saturated with electronic devices that emit various forms of electromagnetic waves and frequencies. From televisions and laptops to Wi-Fi routers and smartphones, these technologies operate by transmitting signals across a range of frequencies. While essential for communication and functionality, concerns persist about their potential disruptive effects on human health. This article explores the types of electromagnetic waves emitted by common devices and the ongoing debate regarding their biological impact. Types of electromagnetic waves emitted by devices. 1. Radio frequency, RF, radiation. Devices, smartphones, Wi-Fi routers, tablets, laptops, Bluetooth devices. Frequency range, 30 kHz to 300 GHz. Purpose: RF radiation facilitates wireless communication by transmitting data over the air. Wi-Fi and cellular networks operate at frequencies typically around 2.4 GHz or 5 GHz. Potential impact: RF radiation is non-ionizing, meaning it does not directly damage DNA like ionizing radiation, e.g., X-rays. However, prolonged exposure and the proximity of devices to the body have raised questions about its potential link to cancer, neurological disorders, and sleep disturbances. 2. Extremely low frequency, ELF, radiation. Devices, televisions, computer monitors, power lines, electrical appliances. Frequency range, 3 Hz to 30 kHz. Purpose: ELF radiation is associated with the operation of electrical currents and magnetic fields generated by electronic devices. Potential impact: some studies suggest that chronic exposure to ELF radiation could interfere with melatonin production, contributing to sleep disturbances and possibly increasing cancer risk, although definitive evidence remains elusive. 3. Microwave radiation. Devices, microwaves, radar, cell phones, Wi-Fi routers. Frequency range, 300 MHz to 300 GHz. Purpose: microwaves are used for data transmission and heating, e.g., in microwave ovens. Potential impact: intense microwave radiation can cause tissue heating, but the levels emitted by consumer electronics are generally low. There are concerns about long-term exposure, particularly with close-contact devices like smartphones. 4. Blue light, visible spectra. Devices, LED screens, computer monitors, tablets, smartphones, televisions. Wavelength range, 400 to 495 nanometers. Purpose: blue light from screens enhances brightness and clarity. Potential impact: excessive exposure to blue light can lead to digital eye strain, computer vision syndrome, interfere with circadian rhythms, and suppress melatonin production, potentially disrupting sleep patterns. 5. Infrared radiation, IA. Devices, remote controls, heat lamps, infrared cameras. Wavelength range, 700 nanometers to 1 mm. Purpose: infrared radiation is primarily used for communication and heating. Potential impact: prolonged exposure to high-intensity IR can cause thermal damage to the skin and eyes, but consumer devices emit low levels that are generally considered safe. Potential biological disruptions. 1. Sleep disturbance and circadian rhythm disruption. Cause: blue light exposure from screens suppresses melatonin, a hormone critical for regulating sleep. Impact: delayed sleep onset, insomnia, and reduced sleep quality. Evidence: multiple studies have demonstrated that blue light exposure in the evening significantly affects sleep cycles. 2. Neurological effects. Cause: RF radiation from phones and Wi-Fi is speculated to affect brainwave patterns. Impact: some users report headaches, dizziness, and brain fog after prolonged exposure to electronic devices. Evidence: research is inconclusive, with mixed results on whether RF radiation significantly affects brain function. 3. Electromagnetic hypersensitivity, EHAs. Description: a condition where individuals report adverse symptoms, headaches, fatigue, skin irritation, when exposed to electromagnetic fields, EMFs. Controversy: while some attribute EHA symptoms to EMF exposure, most scientific reviews find no consistent link between EMFs and reported health issues. The condition may stem from psychological or nocebo effects. 4. Cancer risk. Cause: long-term exposure to RF radiation, particularly from mobile phones. Evidence: the World Health Organization, WHO, classifies RF radiation as possibly carcinogenic, Group 2B. Studies have shown a potential association between heavy cell phone use and gliomas, a type of brain cancer, though the risk remains low and further research is needed. The disruptive frequencies and electromagnetic waves emitted by modern devices stem from the fundamental processes of electricity, magnetism, and signal generation required for their operation. The root causes can be traced to the following factors. 1. Electric currents and oscillating circuits. Root cause: the movement of electric charges, currents, through conductors generates electromagnetic fields. When circuits oscillate at specific frequencies to transmit data or signals, they emit electromagnetic waves. Example: in Wi-Fi routers, oscillating electric currents in the antenna generate radio frequency, RF, waves, which carry data wirelessly. 2. Resonance and harmonics. Root cause: electronic components, such as capacitors and inductors, resonate at specific frequencies, producing harmonics, additional frequencies that are multiples of the base frequency. These harmonics can extend into ranges that may interfere with biological processes. Example: switching power supplies in laptops and televisions operate at high frequencies, often generating harmonics that produce low-frequency electromagnetic interference, EMI. 3. Semiconductor behavior, transistors and chips. Root cause: semiconductors, the building blocks of integrated circuits, ICs, switch rapidly between on and off states. This switching creates pulses of electromagnetic radiation at radio and microwave frequencies. Example: microprocessors in laptops emit RF radiation as a byproduct of their high-speed processing cycles. 4. Signal transmission and antennas. Root cause: devices that communicate wirelessly, phones, tablets, and Wi-Fi routers, use antennas to send and receive signals. The act of transmitting data inherently involves emitting RF and microwave radiation. Example: mobile phones transmit signals by modulating electromagnetic waves at frequencies ranging from 800 MHz to 2.5 GHz. 5. Power supplies and transformers. Root cause: transformers and power supplies, essential for voltage regulation, create electromagnetic fields, EMFs, as they convert alternating current, AC, to direct current, DC, or change voltage levels. Example: the power adapter for a laptop emits low-frequency electromagnetic radiation during the conversion process. 6. LED and LCD screens, blue light emission. Root cause: LED and LCD screens use backlighting systems that produce blue light as part of the visible spectrum. This light, while essential for screen clarity, has shorter wavelengths and higher energy, which can disrupt circadian rhythms. Example: smartphones and tablets emit high levels of blue light from LED backlighting, contributing to digital eye strain and sleep disturbances. 7. Pulse width modulation, PWM, in displays and devices. Root cause: PWM is used to dim LED screens by rapidly switching the backlight on and off. This flickering, though often imperceptible, can produce subtle fluctuations in EMFs and visible light that strain the eyes and nervous system. Example: dimming a laptop screen through PWM can result in invisible flicker, contributing to headaches and fatigue. 8. Grounding and electrical leakage. Root cause: imperfect grounding or faulty wiring can lead to stray electromagnetic fields and leakage currents that radiate low-frequency waves into the environment. Example: old televisions or improperly grounded computer monitors may emit ELF radiation from electrical leakage. Material properties and behaviors. Conductive materials, copper, silver, essential for signal transmission but also facilitate electromagnetic wave propagation. Ferromagnetic materials, iron, nickel, found in transformers and inductors, these materials amplify magnetic fields, contributing to ELF emissions. Semiconductors, silicon, gallium arsenide, essential for microchips but inherently generate EMFs during operation. Feedback loops and crosstalk. Root cause: in complex electronic circuits, signals can unintentionally couple between nearby conductors, creating electromagnetic interference, EMI, or crosstalk. This interference can produce additional noise and radiation. Example: data cables near power supplies can pick up stray signals, amplifying unwanted frequencies. Protective measures and mitigation. 1. Limit screen time before bed. Reduce blue light exposure by avoiding screens at least 1 hour before sleep or using blue light filtering applications. 2. Use headphones or speakerphone. Keep mobile phones away from the head during calls to minimize direct RF exposure. 3. Maintain distance from Wi-Fi routers. Place routers in common areas, not bedrooms, to reduce overnight exposure to RF radiation. 4. Enable night mode. Many devices offer a night mode that reduces blue light emission. 5. Use shielding devices. 6. Natural shielding. Some studies suggest that certain plants may help absorb EMF radiation. Actually, all plants absorb radiation to some level, but these plants have the power to absorb more than others. Cactus, snake plants, aloe vera, stone lotus flowers, asparagus ferns, mustard greens, beetle leaf plants, spider plants, fiddle leaf plants, erica palms, sunflowers, rubber plants, English ivy, and split-leaf philodendron. 7. Device settings. Many devices have settings that can reduce EMF emissions. Enabling airplane mode when not actively using wireless functions. Using wired connections instead of Wi-Fi when possible. Reducing the brightness of screens, which can lower overall energy output. EMF shielding materials, such as fabrics or cases, can reduce exposure from phones and laptops. The scientific debate. The debate surrounding the biological impact of electromagnetic waves remains highly contentious. Proponents of harm theory highlight correlations between device usage and increased incidence of sleep disorders, cancer, and EHA symptoms. Skeptics argue that the majority of scientific evidence points to negligible health risks, emphasizing psychological factors and placebo effects. Conclusion. The disruptive waves from modern devices originate from the fundamental processes governing electricity and magnetism, as well as the physical properties of the materials used. While these emissions are largely unavoidable, shielding techniques, improved circuit design, and stricter manufacturing standards help minimize their biological impact. While the scientific consensus indicates that low-level electromagnetic waves from consumer devices pose minimal health risks, the precautionary principle remains vital. Continued research and evolving technology will further clarify the extent of potential disruptions and guide the development of safer, more human-friendly electronic environments.